Welcome to qnawire.
So we have the following reaction here. We have a methyl ester, which is being reacted with lithium iodide in the presence of a DMF solvent and forming carboxylate ion, as well as our iodomethane. So we want to try to kind of propose an arrow pushing mechanism to explain what's going on. This one's a little bit tricky, but the question gives us two pieces of evidence that we can kind of, so we can try to figure out what's going on here. So the first piece of evidence that we get is that the reaction is going to occur faster in DMF than in ethanol. So we know that DMF is a polar aprotic solvent, and we know that polar aprotic solvents tend to favor SN2 reactions. And the second piece of evidence is that so the corresponding ethyl ester is going to cleave much slower than the methyl ester, and so we can infer that steric effects have a strong impact on the reaction. So we can make a little note here and say that so steric effects influence the reaction. And so from these two pieces of evidence here, we might infer that we have an SN2. So we can go ahead and draw an arrow pushing mechanism for that. So we're going to go ahead and draw our iodide coming in here, which is going to come in for a backside attack on this carbon here. And this carbon-oxygen bond is going to break, and the electrons are going to go to the oxygen. And it looks like that is going to give us the desired product. And so the question also asks us to give some other kinds of experimental evidence that would support our hypothesis of an SN2 type mechanism. So let's say if we were going to propose experiments, maybe we can take advantage of the fact that we have an SN2. If we have an SN2, we have a second order reaction. So therefore, our reaction rate will depend on both the nucleophile and the alkyl halide. Whereas in an SN1, the reaction rate is only going to depend on the alkyl halide. So we can take advantage of that, and let's say for experiment one, we can vary the concentration of lithium iodide and such that when we vary the concentration of lithium iodide, if our reaction rate is changing, it's likely that we have an SN2. And if there is no change in our reaction rate, we probably have an SN1. So for experiment two, again, we can take advantage of our second order reaction rate. And let's say we vary the type of nucleophile. So we use a combination of weak and combination of strong nucleophiles. And if we see that the reaction rate is being affected, once again, we likely have an SN2 type reaction. And if there is no change in the reaction rate, if we vary the type of nucleophile, it's likely that we have an SN1.